day everyone, myself Vandana, Assistant Professor, Department of Computer Applications, SFR College for Women. Now I am going to deliver you a video lecture on the topic Applications of Stack in Data Structures. Before we move on to the topic, let us see some introduction about the stack. Stack is nothing but a linear data structure that is used to store data elements in the strategy called LIFO. LIFO means last in first out. Here the insertion operations are also called as push, the deletion operations are called as pop. Here these are the examples of the stack which is listed out in the figure. In the first example, there exists a stack of coins. Here we can perform the insertion only at the top, that is to place a new coin it is possible only through the top end, not at the bottom end. Here in the second option there is a stack of plates. Here too we can perform the insertions only at the top and also deletions can be performed only at the top of the stack. Here there is a third example called the can of tennis balls and the fourth example called stack of books. So in all these illustrations the insertion is possible only through the top end and also the deletion is possible only through the top end. Here this is the strategy of stack. This strategy is used to store element in the memory using stack. So move on to our topic. These are the applications of the stack. The first one is infix to postfix conversion and the second one is evaluation of postfix expressions and the third application of stack is delimiter checking and the fourth one is reversing a data and the fifth one is processing the function calls. First let us see about infix to postfix conversion. Before moving to the conversion, first we are going to know what is infix and what is postfix. These are both are the expression writing format. Generally we all know that arithmetic expression consists of operators and operands. Here the order of evaluation of the expression is mainly depending upon the parenthesis placed in the expression. For example, the result of the two expression a plus parenthesis b into c parenthesis close and parenthesis a plus b parenthesis close into c are different. So, to avoid the conflicts raised based on the parenthesis, the system will always follows a format called postfix expression to evaluate. Postfix expression means it is a parenthesis free expression. The other name for postfix expression is a reverse Polish notation. Here the evaluation is mainly based on the operator precedence. So this is an example for postfix expressions. Here in the left column the infix notation is placed and in the right column postfix notation is placed. For example, if my expression is a into b means in the postfix notation it will be written as ab into. That is in the postfix notation first the operand must be placed, after that the operator must be placed. And another one point is that in the postfix notation there should not be any parenthesis. Consider a second example, parenthesis a plus b divided by c. Here first the expression within the parenthesis must be first converted into the postfix, that is ab plus and then after that c division. And then like that in the third example a into b plus d minus c, the expression can be written as ab into dc minus plus. So this type of notation is called as postfix notation. This notation is always followed by the computer system to evaluate an expression. So let us move on to the infix to postfix. Here these are the steps for the conversion. First scan the expression from the left to right. Based on the each scanned character, the following steps must be done. So if my scanned character is an operand, then just output it. If my scanned character is an operator, then do the following steps, that is push into the stack. Before pushing onto the stack, check whether there exists any already operator which contains a precedence higher or equal than the current scanned character. If it exists means then pop that character out from the stack and then push the scanned character. Likewise, up to the last character of the expression the steps must be carried out. After that fully the stack will be popped out. Let us see with a clear example. Consider expression a into b into c plus d into e plus f. Here the tablet column clearly shows the current status of the stack and the output postfix strings. So, the second column intimates current token, the third column intimates the operator in the stack, and the fourth column intimates the output postfix string. Here first the current scanned character is A, as it is an operand, it will be sent to the output. So, the postfix string contains the character A. The second character is star, it will be pushed to the stack. So, the operator currently, the stack currently contains the operator star. And the next character is open parenthesis. So, if a character is an open parenthesis, then it will be pushed directly onto the stack. So, currently the operators in the stack are star and parenthesis. And the next operator we scanned is B. So, as B is an operand, it will be output to the postfix string. So, the result is AB. And the next character is star. As it is an operator, it will be pushed to the stack. So, comparatively the star has the higher precedence than the curly brace, that is open parenthesis. So, it will be automatically pushed to the stack. And the next the character scanned is C, as it is an operand, it will be pushed to the, it will be moved out to the output. And the next character scanned is plus. So, plus, before pushing the plus to the stack, first the precedence of the star must be checked. As it is higher than the plus, it must be popped out first and then the plus must be pushed onto the stack. So, plus will be pushed onto the stack and the resultant string will be A, B, C star. The next character scanned is D and it will be output to the postfix strings, and the next character scanned is star. As it is higher than the already existing operator plus, it will be pushed onto the stack. And the next character scanned is E, it will be output to the postfix strings, and the next character scanned is close parenthesis. So, if the scanned character is closed parenthesis, then what we have to do is pop the stack until we see the open parenthesis. So, we are going to pop first star and then plus. As we reach the open parenthesis, then in that stage we will stop. So, the next character scanned is plus, it will be input to the stack, and next character scanned is F. So, with that the expression ended. So, the remaining operators in the stack will be popped out. So, finally, our postfix string is ABC into DE into plus star F plus. So, like this the infix notation can be converted into postfix using stack. So, let us move on to the second application. The second application of stack is evaluation of postfix expression. So, here the steps are as follows. First, you have to scan the expression from left to right. Based on this scanned character, the following steps will be carried out. So, if my scanned character is an operand, just push it on the stack. If my scanned character is operator, then pop 2 operand from the stack, then execute that 2 operand with the operator and store the result back to the stack. So, let us see clearly with an example. Let my expression be 3, 4 star 2 plus. So, this is an postfix expression. So, first 3 is a scanned character, it will be pushed directly to the stack, and then 4 is a scanned character, it will be pushed to the stack. So, the next character scanned is star. As it is an operator, 2 operand must be popped out from the stack. So, 4 and 3 will be popped out from the stack. It will be executed with the operator. So, 3 cross 4, the result is 12. The 12 is stored back to the, pushed back to the stack. So, then the scanned character is 2. The 2 is pushed to the stack. Then the scanned character is plus. As the scanned character is an operator, 2 operands will be popped out from the stack. So, 2 and 12 will be popped out from the stack. So, plus will be applied to 2 operands. So, 2 plus 12 is equal to 14. So, 14 will be stored back to the stack. So, likewise we can get the final result. So, here the final result for the expression is 14. So, like that postfix expression can be evaluated easily using the stack. So, then let us move on to the third application of stack, that is delimiter checking. So, delimiter is nothing but a special characters used used as a parenthesis, like that open parenthesis, closed parenthesis, curly braces, square bracket, comma, like that. So, here the purpose is it can be used during the program's compilation in the programming languages. Maximum this application can be used by the compiler. For example, if my compiler compiles my program, means it will have to check if there is a opening parenthesis, there must be a closed parenthesis. If there is a opening bracket, there must be a closed bracket. So, it is the duty of the compiler to check that in the programs, in the programming languages. So, for that purpose stack can be used. Here what stack check means, if there is a open delimiter inside the stack, there must be a closing delimiter. So for that the steps are as follows. So push the open delimiter onto the stack. If a scanned character is a closing delimiter, then pop the respective opening parenthesis from the stack. So if there is any mismatch between the opening and closing parenthesis means, it means that there is a error. If no mismatch means no error. So like that the step executes until the last character in the stack. So in the end, if the stack is empty means, then there is no error. If the stack contains any character means, then it clearly intimates that there is a opening parenthesis without a closing parenthesis. Let us discuss with an example. So here consider a expression with an unbalanced delimiters, that is curly brace, open square bracket, open parenthesis, then after that close square bracket, close parenthesis and close curly braces. Let us push one by one character to the stack. The first character is curly brace and the second character is square bracket. So these two are pushed onto the stack, and then the third character is the open bracket. These two is pushed into the stack, and then the scanned character is closed square bracket, but the operator on the top of the stack is open parenthesis bracket. So these two characters mismatches. So this clearly intimates that there is an unbalanced delimiter. So like that, if my scanned character is closed parenthesis means, then there is a match. So it intimates that there is no error. So likewise, unbalanced delimiter can be checked. So this application is particularly used by the compilers in programming languages. So then let us move on to the fourth example. So it is an easy application of the stack. So stack can be used to reverse a given data. So this is default that stack always uses the LIFO strategy, that is last in first out strategy. So the given data can be easily pushed one by one character onto the stack and then pop one by one. So automatically the character will be reversed. So let us see with an example. My string is welcome. So welcome is scanned one by one character and is pushed onto the stack. So WELCOME. So in my stack there exists 7 characters. So let us consider the example that contains a string WELEOME. This is my given string. The given string must be placed one by one character into the stack. So it is popped one by one from the stack. If it is popped means the output string is EMOELEW. So likewise the given data can be pushed one by one to the stack and popped one by one to the stack. So from the stack. So if it is done means the given data will be automatically reversed. So the last application of the stack we are going to consider is processing function calls. This is the application used by the system functions, that is by the compiler, loader, linker. Likewise the system programs will use such type of applications. Here what the stack done means, if a program contains a function call, there exists a necessity that the function must store the return address of that. So for that purpose stack will be used. The stack is used here to store the return address of every function call during the function call. So this is a system stack. Let us see it clearly with an example. Here there exists a main function. So within the main function I am going to call a function called A. So before going to execute the function A, the return address of the A must be stored onto the stack. So parallelly we see the stack. First in the stack contains the address of A. So then the execution move on to the A function. So in the A function, B function is called. So here we have to store the return address of B. So automatically address of B will be stored in the stack. And here in the execution of B, the C function is called. So here we are going to store the return address of C in the stack. So here then the execution of C will be done. After the execution of C, the execution flow must be returned back to the B. Then that address can be found using the stack which contains the address C. So after that execution of B, then the return address of B can be found, and after the execution of A, the return address of A can be found. So likewise the return address can be stored using the stack. This is also applicable using for the function recursive calls too. So, we have seen 5 application of stack. As I already said, stack follows the LIFO strategy. So, it is a versatile one that can serve diverse applications. So, in variety of application we can use stack. Let us consider for decimal to binary conversion too, we can use stack. So, these are the exercises, just to try it and check the answers. Thank you for watching.